Have you ever wondered how lightweight carbon bikes are made? Today you're gonna find out. Welcome everyone, we're here with Bryce from Alchemy. We're gonna do a quick tour of the Alchemy workshop.
This is our showroom, so this is a great place for us to display kind of one of each of everything that we make. Right. So if you're interested in an Arctos, you can see it. If you're interested in a Ronin, you can put your hands on it and feel it. And then typically this process is so involved and takes such a long time. We like to have a nice comfortable space to sit, have coffee, beer, beverages, and really kind of work out what's important to you, what's your build gonna be like, and just take our time to do that.
We'll just get into what the building of that looks like.
Yeah, the exciting part.
The exciting part. So what's going on here?
So this is the workshop, the Alchemy workshop. This is where we fabricate. This is the titanium area. Our welder, Jeff, has been with us for a little over a decade. He's a one-man show. He does everything from cold forming the tubes, mitering them, welding them, and finishing them. So.
Sorry, what does that mean? What does the cold forming mean?
Cold forming, so you'll notice here at the top part of this tube, it's perfectly round.
Yeah.
But as we get down to the bottom, it's flattened out. So we use a 12-ton press to actually form the tubes.
Wow.
And he puts all these nice XC curves into the seat stays and chain stays all by hand. So he's
That's insane.
He's very good at what he does.
This looks like it's not someone's head tube.
That is someone's head tube.
This is someone's head tube.
Yeah, so
I was gonna say, you're about to cut this or something? Like, this is insane.
Yeah. Well, that's kind of what we specialize in. We custom fabricate frames. So people find us who maybe can't get a bike off the peg that works for them. We have a fit studio upstairs. We'll put them on the retool machine. We'll figure out their sizing and design a bike that's tailored around their body. Yeah.
So this is titanium?
Yep, this is the titanium area.
This is the presses you were talking about?
Yeah, so that red thing in the back, that's the hydraulic bottle jack press. We've got a tube mandrel over there that we can shape the tubes with. And then all the old bridge ports is for mitering the tubes so that they fit perfectly, for reaming the seat tubes, all that stuff. That's a whole lot easier done with a machine than with files by hand.
That would take a while.
Yeah. This is an AU frame. This is what your frame looked like before it had paint on it. He had to put on a leveling coat so that you wouldn't feel all these, all the imperfections in the carbon.
This feels fragile.
It's not. It's really, really robust.
I know it's not, but like it feels like I'm gonna drop it and it's gonna fall into 1,000 pieces. I mean, I don't know how like usually they're made. Like, how's that different from like mainstream brands? Like, what do they do that it's not?
Yeah, most larger brands, most frames are made in Asia, and they're made in what's called a monocoque construction. So that means that this whole front triangle is going to come out in one piece.
Gotcha.
We do a tube-to-tube construction, which is a lot different than most of the carbon bikes you're going to find elsewhere.
Right.
What that means is that we fabricate the down tube independent of the top tube. The seat stays are made separate from everything else.
Kind of like the titanium bikes.
Exactly like a titanium bike, but instead of welding it, we overwrap it. So we put it in the jig. Yep. We put it in the jig just like that. And instead of welding it, we wrap a bunch of pieces, a bunch of sheets of carbon around all those tubes to hold them all together. And then we create a big vacuum bag that the whole frame goes in, and that sucks down on it. And then we put it in the big oven here.
That's what this is?
Yep. And that heats it all up and joins it as one frame. I think we keep it like around 160 degrees, and that frame will bake in there in the bag for around 3 hours to cure everything together. Building tube to tube allows us to fine-tune the layup schedule in each individual component. Because your down tube needs to behave differently than your top tube does. So we can build a frame that's really vertically compliant, super comfortable, but at the same time is incredibly laterally rigid. So something that rides like you want it to when you're on a 100-mile ride, but accelerates like you want it to out of a corner in a crit race. But that tube-to-tube construction also allows us to do custom geo. So just like on the tie frames where we can make that bike to fit you, we're one of the few companies that can make a carbon frame to fit you as well.
And it's made here in the US.
It's made right here.
In Golden, Colorado.
Yep. I'll show you how your frame's fabricated. So we use the same jigs for carbon and tie. Okay. So everything can be held in this jig.
So you'd have all the like tubes separate, like you have on that bike.
Yep. So
to test it out.
just like here, we've got
That's very cool.
a top tube, we've got a down tube, and we'll miter those, and then the jig will hold everything in place, basically just to test fit everything, make sure that those miters are...
So you make these first.
Yep.
And then you adapt them to the person's geometry.
Yep.
And then you do the gluing, like the that you showed, the layers.
Yep.
And then oven.
Yep.
Crazy.
So all these tubes are made to be mitered at one end, so this end will stay the way it is, and then we can miter this down as
much
short as we need to. We put a thin coat of glue to hold it all together, and then we take it out of the jig and we put it in a stand to overwrap it. But yeah, all the pieces come out just like that individual.
Oh, it feels very fragile. Let's take this out. I'm pretty sure the paper in our printer is heavier than this. Like literally. Like a fork. Like an eating fork. Yeah.
All these parts are made to slot together.
Right.
So they fit. So he'll
like building a Lego.
He'll machine these so that it's a really tight fit and that these are perfect. And then we can just wrap carbon sheets around this. That's why they're recessed, so that we can build the carbon
and then it's
up.
flat.
Probably the coolest because they're the most intricate shapes that we make. For these, instead of using like an inflatable bladder, we actually use silicone, which expands as it gets hot. So we wrap all these sheets around this silicone form, and then we put it in a mold and we heat it up, and that silicone expands into the mold and then produces
so then you you just have these for like all the different types of bottom brackets that you have on the bike. It's insane how thin this is. Like I feel like I'm about to rip it. Like I can't even show, like it's minimum thinness.
This is not what you have, but this is our...
This is for electrical bikes?
Yeah, this is for an e-bike. We make custom e-gravel bikes. We're the only manufacturer in the US that does that. And actually this is probably the most intricate piece we make. This is one piece.
So then this would be the bottom bracket.
Yep, so this is where the motor bolts into, and then this is where the battery sits inside of the down.
So you're basically doing that piece of the bottom bracket plus
the head tube and
all
the
this
down tube.
in one.
Yep. If we want to go in here, this is the layup room. This is where all the carbon magic happens.
Ooh, carbon magic.
Carbon magic. So this is a CNC plotter. Basically, it's a computer-guided cutting tool. So this is all sheets of carbon on the table. This is basically like a reverse hockey table. It sucks air down and holds the sheets of carbon onto the surface.
Like a vacuum type thing?
Yep, exactly. So it just kind of sucks the sheets down, and then this will cut out the shapes that it needs.
And this is carbon?
Yep. It's carbon with a backing paper on it.
This is carbon. It feels like paper, like a sticker.
Yeah, basically. So you can see pretty well here how these fit together.
Wait, that's literally carbon.
Yeah. So most all frames are made out of what's called a pre-preg carbon. So it's pre-impregnated with a resin structure.
Okay. That's what holds it together.
Yep. So this piece is pretty new, so you can still feel that it's really tacky. But this is 2 sheets of carbon applied together. So all the carbon that we use is unidirectional. It means all those strands are running in one direction, and then we need to cut them so that they can run in different orientations.
And you always use 2 sheets to make one piece?
The least amount we use is 6 sheets of carbon in one tube.
And it's still that thin?
Yeah. Yeah, because all that resin's getting pushed out. There's a ton of force pressing that carbon. The bladder's pressing it into the mold, so it presses it really, really thin, and a lot of that resin seeps out. So yeah, it gets very thin. But yeah, so it all comes on big rolls, and it rolls out in what's called a 0 direction. So all those fibers are running in a 0 orientation, and then we will cut those sheets and turn them so that the fibers are running in 45 or 30 or 60 or 90 degree angles. And depending on the component that we're making, we need those fibers to brace each other a certain way. So if we want to make a really rigid piece, we're going to use a 90, a 0, a 60, and a 30, so that we just
they're
have
like
fibers
against each other, basically.
Exactly.
Okay.
Yeah, we've got a nice little tool here that we can kind of display how it works. So these are the same thickness, same sheets. but these are all running in a 0 orientation, and you can see how bendy it is, and then these ones are bracing each other, and you can see how firm it is. So
can you see it?
Yeah.
Oh yeah, you can. So like that is basically just like a straight line, and it bends quite a bit. And then this, you see them going everywhere. Kinda. It really doesn't want to bend. That's crazy. So then, do you like do different thickness or strengths depending on where the part is going to be used?
Exactly. Yeah. So bottom bracket, we've got fibers running in every direction because we want that to be really rigid. But like your seat tube is mostly 0 fibers. They need some bracing so that they're strong, but we want it to be a lot more flexible. That makes a lot of sense. Sometimes we get guys that they're like a 280-pound crit racer. We know that they're going to flex their bike a lot, so we will overbuild their chainstays, their bottom bracket, their down tube.
Thicker, stronger.
Exactly, because we know their use case because we've had that conversation with them, and we know their strength and their body, and so we can build a frame to
That's very cool.
adapt to them.
Which is a huge difference to just taking a frame off the shelf.
Yeah.
At whatever brand.
Yeah. So over here you can kind of see these are training tools that we use to teach composite technicians how to overwrap.
Okay.
So these are just tubes that are joined together. These have a lot of glue on them, but you can see all of these are different sheets. Every line is a different sheet of carbon that's wrapping around this tube. We use these little sheets cut in different sizes, and basically we will join them.
It's insane that's carbon. It looks like you're putting a sticker.
Yeah, it's basically a carbon sticker. But yeah, so we'll heat it up, and we'll heat it up with our finger. Typically you're wearing gloves. But just to show you how that works, so if we heat it up, we can really ply it around this tube. And so that's kind of how those are joined. We stack them up. One reason we stack them is to just prohibit a hard line forming right there. We kind of want to spread that out.
Right, so there's not one spot where you could just snap.
Well, that's the other part. But yeah, so that it's not just like a hard line where you can feel it. If we stagger it, it's a lot more smooth. But yes, if we just ended them all at the same place, there would be a lot of stress right there where they end, and we'd have a higher probability of it failing right there. The only time we really use 3K weave, which is what most people think of when they're thinking of carbon, you can see that kind of that woven structure.
Like the famous carbon thing.
Yep, so this is really hard to tune how it feels because it's just fibers running in every direction.
Which is what this is.
Right. So we use this when we need a piece to be really, really strong, and it doesn't really matter so much how it behaves. So like dropouts, that is basically just solid carbon because they are clamped and they just need to not move. We'll use this, but for the most part, we just use unidirectional because we can change how it behaves. Over here, these are basically just, like we can fit an entire bike inside of one of these bins.
That's just like someone's bike.
Yep.
That's literally someone's bike.
Somebody's flat bike right now.
That's hilarious.
So you can see a lot of the unique shapes that CNC plotter will cut. These are actually for seat stays. So this is where the seat stays will come out, and this will form the piece that attaches to the seat tube. This is a frame after it's been overwrapped, right after it comes out of the vacuum bag. So you can still see the texture from the bag on the overwrap.
Oh yeah.
So it's actually the texture that the bleeder gives it. So the bleeder helps suck all of the excess resin out of it. So the bag's pressing down on it. We've got like a kind of cotton layer, and then the bleeder touches the frame. So the bleeder soaks it up, puts it into the carbon layer, and then the bag is on the outside.
This paint is the first paint that you do.
Yep, so this is a Magna coat, so this is the leveling coat, so you could feel all the texture on that, you can feel the layers, and then once we lay down a leveling coat, then all that texture and all of those layers go away, and then we can put down a really smooth paint job on top of that. This is an e-bike, so this is what it looks like before it gets overwrapped. So you can see that they're glued together here. We'll sand off all that, and all that's left is the glue that's in between.
So this is right after you just put all the pieces together?
Yep, so this literally came out of that jig looking like this. So that jig held all these places, or all these parts in place while that glue dried, and then we can take it out of the jig, sand it down, overwrap it, bag it. This is another kind of cool thing, yeah. So this is a freezer. This is somebody else's bike, yep. So we keep everything at 0 degrees until it's being used, because that resin structure will start curing over 0 degrees.
Are these rolls of carbon?
Yep, so this is just a roll of unidirectional carbon. Each of those carbon, so like the AU is made out of a high GSM carbon, so it is thinner and stronger, more rigid. So each roll does a different job. The molds is pretty cool. We've got like a different mold for everything. You can see they're labeled by the model
of the bike.
Most of them we have one mold for each individual component, but some like the E-Ronin or E-Gravel bike, there's a different size for each bike since they're made in that big piece. This is a seat stay. So it's very heavy. So we machine these pieces. So our engineer will create a CAD file on the computer. He'll transfer that to our lathe, and then our lathe cuts these pieces.
Oh, that's the little fork.
These are the seat stays. So basically how this works is we roll up the sheets of carbon like a cigar kind of, with a bladder in between them. We use silicone and latex bladders depending on the part, and then we'll just lay that down in here. We'll lay each one in there and then wrap both of them together. And then these are gas fittings. So on the end of each of those bladders, we have a fitting that sits right in here. And when we put the top of this piece on, those gas fittings are still exposed. We'll bolt the two molds together, and then we can use those fittings to inflate the bladders inside of this mold with nitrogen. It's a really heat stable gas, because we're going to heat it up to about 260 degrees on the heat press. And we bolt them together so that that expansion doesn't separate the mold and we don't get carbon leaking out into this space here.
Makes sense.
That heat press also puts down, I think, around 40,000 pounds of pressure, those two platens, to keep this from exploding. Because we put up to around 180 PSI in some of the parts. That's a lot of pressure inside a very small space. So we don't want bolts shooting out all over the place. So safety measure. The heat press I was telling you about, these all close. So they'll press together and just squish one of those molds in between them. And then these all heat up. And so that's what gives you the heat is what cures the resin inside the carbon.
How long does that process take?
The molds only sit on here for about 30 minutes.
Wow, that's really fast.
Yeah. So at 260 degrees with all that pressure inside, they heat up really quickly and they cure really quickly. This one, because it's a lot lower temperature, we leave it in there for a lot longer.
Paint booth. Ooh, colors.
Ooh, lots of colors. Our painter Phil has been with us for a very long time. He's exceptionally good at what he does. He does wet paint and Cerakote. We got a big mixing bank here. This wall, we can create thousands and thousands of different colors. We got a handy little computer that tells us exactly how much paint goes in to make each individual color. Well, this is all automotive paint, but most of it people can pick. The easiest way for them to pick is based on the color of a car that they like.
Yeah.
So if they're like, hey, I've got a Toyota Tacoma, I want my bike painted to match, we can just pull that color.
That's pretty sick.
Mix it on the computer and it matches perfectly.
Could you explain a little bit, I know you explained to me, but explain to everyone else the difference between, because I didn't know, the wet paint and the Cerakote and like what that's about.
Yeah, so wet paint, it is a lot thicker, it takes longer to cure.
And that's what we're used to, right? Like that's what you see most often is the wet paint, and that's what it's called.
So you'll see some powder coating more on like aluminum bikes. That's a really thick, really resilient coating that's adhered through electrical current. And then there's wet paint, which is the most common. It's super durable, it's easy to apply. There's a lot of different options in terms of finishes and colors and
matte, glossy.
Matte, gloss, satin, all the different pearls and metal flakes you can put into it. So it's really versatile and unique. And then Cerakote is pound for pound probably the strongest coating. We lay it on in exceptionally thin coats that are just microns thick. and it's really, really tough still.
It's really light as well, right?
It's very light. So that's why we use it on the AU frames, which is what you're getting. It's because we can keep that weight down to a real minimum. The coating on most of the AU frames comes out around 5 to 8 grams for the complete bike, which is like less than, it's like a paper clip.
And like a wet paint would be 100 plus.
Wet paint, I think, is like right around 120. Yeah.
That's 5%.
Yeah. There's not as many colors to choose from in Cerakote. You can't do quite as many things with it, but it's a really great application, especially for stuff like gravel bikes where you need it to be resilient to rock chips and stuff like that. Bennett is the one who takes care of everything at the very end of the process. So after everybody has taken their time fabricating your frame and painting it, the handsome Bennett lovingly assembles your bike and carefully packages it and ships it off to you. This is where the bikes sadly depart us and you get a new bike day.
The people that don't come to pick it up.
People that don't come to pick it up.
Right. Very cool. And that's it. And then just
That's
like
it.
that, someone has a new bike.
The Alchemy Workshop.
I went from paper to that.
Yeah.
It's crazy. Well, thanks. Appreciate it. And
Yeah.
I can't wait to ride mine.
Yeah.
It's gonna be
excited for you.